Okay guys, go ahead and try this warm-up by yourself. Make sure you put me on pause. Go ahead and do that now. The graphs of the equation y is equal to 2x minus 7 and y minus kx is equal to 7 are parallel when k is equal to what? Well, remember, if two lines are parallel, that means that their slopes are equal. So the slope of the first one will be equal to the slope of the second one. The slope of the first one, this is in y equals mx plus b. So the slope of the first one is equal to 2. So that's got to equal 2 on the second one. So if I take this equation and I unscramble it so it's y equals, I would add kx to both sides, which is one way of doing this. Kx equals, kx plus 7. That means k must equal 2. Okay, be careful. Here's the tricky one right there. All right, 10.5. Graphing square root functions. This is honors level and later on for the regular group. Square root functions. A square root function is a function containing a square root with an independent variable and a radicand. The parent square root function is y is equal to the square root of x. That's the parent function for square roots. The table and the graph below show the parent function show the parent square root function. So if you look at this, if we build a table starting with 0, which is what they did, and we put in 0, 1, 2, 4, and 9, notice how they didn't go 1, 2, 3, 4, 5, 6. The reason why they did that is if you put in y is equal to the square root of 0, square root of 0 is 0. So that's this one. So that works. Then they went to 1. Well, square root of 1 is a perfect square. That's 1. This works. If you go ahead and put in the square root of 2 and you put that into your calculator, it's going to come out to about 1.4. It's actually an irrational number. That's what they did here. Then they thought, well, you know what? Instead of putting in the square root of 3, which would come out to a similar estimation, then they just skipped and they said 3 is not a perfect square, but 4 is. Square root of 4 is 2. And they said, what else is a perfect square? Square root of 5? Nope. What about square root of 6? Nope. Square root of 7? Nope. 8? Nope. 9 is a perfect square. So then they started to look for perfect squares, which you guys can actually do and actually manipulate your domain so that they will work out in the equation. When you go ahead and graph these points, 0, 0, 1, 1, 2, 1.4, 4, 2, and 9, 6, you will notice that it is a curve. Okay, so y is equal to the square root of x. It's actually half of your parabola because it's the inverse. If you think about y is equal to the square root of x and you wanted to get rid of square root, you would square, which means y is equal to, y squared is equal to x. Because you have a squared, you know it's going to be a parabola. Notice how it doesn't say y equals x squared, it says y squared equals x, which means that the parabola is going to be going sideways, which is not something you've been used to, because the x is not squared, the y is squared. Because we only started at 0 and we didn't go negatives, notice that we only had half of it. Plus, not only that, but if you put a negative under the radical, you're going to end up with an imaginary number. So we avoided that, and we just have the positive values. Finding the domain of a square root function. Remember, domain is your x values. Range is your y's. Since x is under the square root sign, the radicand must be greater than or equal to 0. That's what we just talked about. Because you need it to not be an imaginary number. Okay, so what is the domain of the function y is equal to 2 times the square root of 3x minus 9? If you take what's under the radical, we know that this number, whatever it simplifies to, this expression, we want it to be greater than or equal to 0. So if I solve for that, and I don't know if you understand, but the reason why you want this to be greater than or equal to 0 is because you don't want it to be a negative. If this comes out as a negative, then a square root of a negative takes us out of the set of real numbers. So we get 3x is greater than or equal to 9, divide by 3, and we get x is greater than or equal to 3. So therefore, my domain is all the numbers, well, I can write it like this, x such that x has to be greater than or equal to 3. So that would be my domain. If you put 3 in here, 3 times 3 is 9, 9 minus 9 is 0, that works. If I put something less than 3, which shouldn't work, like 2, 3 times 2 is 6, 6 minus 9 is negative 3. Can't have a negative, so that's why it has to be greater than or equal to 3. Build a table and graph it. Graph the function I is equal to 1/5 times the square root of p, which gives the current I in amperes for a certain circuit P in watts. When will the current exceed 2 amperes? Okay, remember I is the amperes. So if we build a table, we've got P, instead of X and Y, we've got P and I, and we're going to go with just our positive values. If I put in 0, that would be I is equal to 1/5 times the square root of 0. Square root of 0 is 0, and 0 times 1/5. 1/5 times 0 is 0. So that would be right here. If I put in 1 right here, square root of 1 is a perfect square, so that wouldn't be a bad idea. That would be 1/5 times the square root of 1. And square root of 1 is 1, and 1 times 1/5 is 1/5, which is equal to 0.2. So 1 goes to 0.2, so that's just barely above it. If I put in 2 right here, that's not a perfect square, so let's skip it. 3, let's skip it. Let's put in 4. If I put in 4, that would be 1/5 times the square root of 4. Well, square root of 4 is 2. 2 times 1/5 is 2/5. Which is still, this should be even lower, though it's very hard to do. Let's see, what else is a perfect square? 4, 5, 6, let's try 9. Square root of 9 is 3. Oops, I don't want to do that. I'm putting it in the wrong spot. So we've got 1/5 square root of 9. Square root of 9 is 3, and 3 times 1/5 is 3/5. Wow, this is barely creeping up. Notice, guys, that this is going very, very slow angle, or arc, excuse me. It says, when will the current exceed 2 amperes? Wow, I am not sure. When would it exceed 2 amperes? In other words, when is this going to reach to 2? Well, try to think of a big, let's do guess and check, or we could set it equal to 2 and solve backwards. But let's try a perfect square, like for example, let's try 81. So if I did 1/5 times the square root of 81, that would be square root of 81 is 9, and 9 times 1/5. That's close because that comes out to 1 4/5. So let's go one bigger than 81, perfect square. Let's try 100. 1/5 times the square root of 100. Square root of 100 is 10, and 10 times that would be 10/5. There it is. So it's greater than 2 when it is equal to what is it, 10 P, the watts. So when P is greater than or equal to 100. That's what I'm looking for. Graphing a vertical translation. Remember, vertical means you're moving it up and down. If you think about the parent function, which we did in the way beginning, that was already shown for us, we picked 0, 1, let's skip 2, 3, 4, let's go to 9. If you put 0 in here, and if you just looked at the parent function, which is y is equal to the square root of x, 0 would be 0, square root of 1 was 1, square root of 4 is 2. That would be this. Okay, so watch this. This is the one you saw on the first screen. Okay, don't connect, or I guess you could connect, it's just hard for me to do it on the array. Alright, so now let me do this in a different color. Now watch what happens. If you have the square root of x plus 2, and I build a new table, and I put in 0, that's square root of 0 is 0, and 0 plus 2 is 2. Put in 1. Square root of 1 is 1, 1 plus 2 is 3. Put in 4. Square root of 4 is 2, and 2 plus 2 is 2 plus 2 plus 2 is 4. Put in the 9. Square root of 9 is 3, and 3 plus 2 is 5. So now watch what happens. 0, comma 2, 1, comma 4, comma 4, and 9, comma. So now look at that new curve. What do you guys notice about the new curve? This point went up 2, this point went up 2, this point went up 2, so that means it went up 2. If you notice right here, this is the indicator. Because they added 2 to this, that means that it was vertically translated 2 units up. That's the plus 2. Anything on the outside, not indexed to the x, is going to do a vertical movement. Anything that we do inside by the x will be a horizontal movement. So let's look at the next one. Here's a horizontal translation. Let's see how much time I have. 3 minutes. Okay, so what is the graph? If you think about the parent function again, remember that was 0, 0, 1, 1, 4, 2, and 9, 3. So that was like this, right? That was the parent function, y equals the square root of x. Now notice, it's not y is equal to the square root of x. They literally added 3 to the x, which is under the radical. So that means it's going to be a horizontal translation, okay? So if we build our table, which will always work for you, let's pick perfect squares again so it works out. So 0, 1, 4, and 9. So what is y is equal to the square root of 0 plus 3? So that would be 0 plus 3 is 3. And the square root of 3 comes out to a decimal. So if you grab your calculator, it's not going to be nice because it's an irrational number. It's going to come out to 1.73. It's going to keep going. Let's do the next one. What if I put in 1? 1 plus 3 is 4. That's going to come out, square root of 4 is 2. If I put in 4, 4 plus 3 is 7, so if I hit the square root of 7, it's going to come out to a decimal again, roughly 2.64, yada yada. If I put in 9, that's going to be 9 plus 3 is 12, so if I hit the square root of 12, it's going to come out yucky again, which is 3.46. I'm rounding these off. So when you graph this, you get 0, 1.7, let's see, 1.73, so 1, 2, 4, 2.6, 9, 1, where am I? 1, 2, 3.46. So you'll, whoops, you can't do this that well. It's hard to make your curve. But there it is. That is y is equal to the square root of x plus 3.